Have you ever wondered why time seems to fly when you're having fun but drags when you're bored? We all perceive time, ticking away second by second, minute by minute. Yet our experience of it can be so subjective, swayed by the roller coaster of our emotions and the flavor of our experiences. But what if I told you this ceaseless march of time, this constant rhythm is not as unwavering as you'd think? In fact, it can stretch and shrink. Welcome to the world of time dilation, a mind-bending concept from the realm of physics. Let's imagine two twins, Earthbound Eric and space traveler Sam. Eric decides to stay on Earth while Sam embarks on a journey into space, traveling at near light speed. Now, here's where things start to get a little strange. In the world as we know it, time appears to pass at the same rate for everyone, right? Well, not in the world of physics. According to the theory of relativity, time does not tick at the same pace for everyone everywhere. It's not a universal constant, but rather a variable that depends on speed and gravity. So, back to our twins. As Sam is hurtling through space at near light speeds, his time is actually passing slower than Eric's time back on Earth. Yes, you heard it right. For Sam, each second is stretching out, becoming slightly longer than Eric's seconds. This is what we call time dilation. You might be wondering, how is this possible? Well, it's all thanks to a guy named Albert Einstein. His theory of relativity revealed that time and space are intertwined in a four-dimensional fabric called space-time. When you move fast, really fast, like Sam, you're essentially distorting this space-time fabric. This distortion results in time ticking slower for you compared to someone who's stationary or moving at a slower pace. Now let's fast forward. Sam returns to Earth after his high-speed space adventure. He expects to reunite with his twin brother Eric, only to find that Eric has aged significantly more than him. While Sam was away, his clock was ticking slower, so he has aged less. This isn't just a fascinating thought experiment, it's a real phenomenon confirmed by precise experiments. GPS satellites, for example, have to adjust for time dilation to provide accurate positioning information. So, in essence, the faster you move, the slower time passes for you. Isn't that fascinating? Now, you might be wondering what causes this strange phenomenon. Well, the answer lies in Albert Einstein's groundbreaking theory of relativity, which revolutionized the way we understand the universe. Einstein proposed that space and time are not separate entities but are interwoven into a single continuum known as space-time. Just as a fabric stretches under a weight, space-time is distorted by mass and energy. This distortion creates what we experience as gravity. But here's where things get really interesting. This warping of space-time doesn't just affect objects, but also time itself. This is a concept we call time dilation. According to Einstein's theory, the stronger the gravitational field, the slower time passes. It's like running in a dream where your legs can't seem to move fast enough. In a stronger gravitational field, time drags its feet. This isn't just theoretical either. Scientists have tested and confirmed this phenomenon. Using precise atomic clocks, they've shown that time actually passes more slowly for a clock closer to a massive object than for a clock further away. So imagine you're standing at the base of a mountain with a clock, and there's another clock at the top of the mountain. Because the gravitational field is weaker at the mountain's peak, the clock at the top would tick slightly faster than your clock at the base. In other words, a clock at the top of a mountain would tick faster than a clock at sea level. Mind-blowing, isn't it? Let's take a moment to recap what we've learned about time dilation. It's a fascinating concept that challenges our everyday understanding of time. We've delved into the twin paradox, a thought experiment illustrating how a journey into space could theoretically cause one twin to age more slowly than the other. We've also looked at the role of speed and gravity in time dilation. The faster you move or the stronger the gravitational field you're in, the slower time appears to pass for you. And let's not forget Einstein's theory of relativity, the cornerstone of our understanding of time dilation. This revolutionary theory tells us that space and time are intertwined in a four-dimensional fabric known as space-time. It's a complex and mind-boggling concept, yet it's integral to the way our universe works. So next time when you feel time is flying or dragging, remember it's all relative. Until next time, keep exploring the mysteries of our universe.